if you want a good installation, you really need to understand the heat loss from your property. Most installers are on the side of putting one in that's too big. If you come from a tradition of gas boilers where you have enormous ones, we had a 36 kilowatt gas boiler and replaced it with a 7 kilowatt heat pump, and I think they're just uncomfortable making that switch to a different form of heating, so they're rather on, well, we'll give you a 10 or a 15, which is, for this property, would have been far too big.
And then you get a badly performing heat pump.
You do, because...
And we see those sometimes on YouTube.
Yeah, and it's probably the biggest cause of poor performance on a heat pump. I thought it might be useful to just go through how to perform basic heat loss calculations. In basic terms, there are two major sources of heat loss from a property. One is fabric loss, so that's the heat loss through the floor, walls, windows, doors and roof. And the other one is ventilation loss. So all properties do need to have some ventilation. And that's just how much air changes an hour there are and how much energy it takes to heat up that air. So every external component has a U value. So windows, doors, etc. have a U value, which simply tells you how much energy you lose for every 1 degree for a square metre. So effectively you just need to use those U values to calculate how much heat loss you would get from the building.
So U value is what, an insulation value?
It's a heat loss value per square metre.
Okay, and so different products have different U values.
That's right. That's what it breaks down to at the end of the day. Just multiplying an area by a U value, by the temperature difference that you'll have from inside and outside the house. And ventilation loss is based on number of air changes an hour, so I'll go through how you calculate that. There's a few different ways you can do the heat loss calculation. My intention is not to go through this in a lot of detail, but just to show you that it's really a very simple concept. So taking a simple room in this house. So this is the playroom. This is the single room I chose to model. So it's got two external walls. It's a corner room, so that's an external wall, and this is an external wall. The external wall area is 7.8 metres, and the height of the room is 2.6 metres. So from that, the external wall is 15 square metres, and then you multiply that by the U value for the wall. And
where do I get the U value from?
So if you go to, and I can put these in the notes. So here's an example of that. So it'll tell you the U value, which is over here, in watts per metre squared. So solid brick, plaster, for different wall types. So this is one source. Another source is from MCS themselves. Have a long list of cavity wall with insulation, rendered brick, so there's a couple of pages of this stuff. Quite a lot of information from here as well, so I can put these sources in the notes. For the playroom, I've got cavity wall insulation, but also internal insulation, so I've got a very good U value of 0.21, and then that is multiplied by the temperature difference. So coming back to this, so working out for a single room, I've got the wall area and the floor area. The windows and doors, I've just measured them and put a square meterage in, and obviously where there are windows there's no walls, so I subtract that area from the total wall area, and from each of those you get a number of watts of energy you lose for a 22 degree difference in temperature between the inside and the outside of the house, which is the design point for this house. So you can see for that room on its own it would lose 178 watts on the coldest day.
Wall area, floor area, windows and door, that's the other one, and then the ceiling.
The ceiling I put a U value of zero because it's a ground floor, so effectively there's no heat loss because any heat that will go into the rooms upstairs. And what you're trying to calculate here is the total heat loss for the house, so you can size your heat pump. So internal walls don't really matter at this stage. When it comes to sizing radiators, they do come into play. So for every room you get a fabric heat loss. So if I just look at this one room, that's 178 watts. So the other source of heat loss is the ventilation loss. So again, it's a pretty simple calculation. Air changes per hour formula is quite straightforward. It's the specific energy of the air, so in other words, how much it takes to heat up 1 cubic metre of air by 1 degree centigrade. Then you multiply it by the number of air changes you assume for the building, by the volume of the building, and via the temperature difference between the inside and the outside. So you're bringing cold air in, which is say 22 degrees colder than the air in the house. So you put that into the formula and it'll give you a vent thermal loss. So in the case of the playroom, the room I've looked at, that would be 287 watts, assuming again one air change an hour.
So that's your length times the breadth of the room times the height.
You multiply 0.33, which is the specific heat of air for 1 cubic metre, by the number of air changes, which is 1, by the volume, which is 40, and by the delta T, which is this 22 degrees up here.
Okay.
The difference on your coldest day. So you can see from that the playroom vent loss is 287, which is quite a lot more than the fabric loss. Now, air changes an hour is a very difficult thing to determine. So the way that is done by MCS is they just work on the age of the property. So if it's pre-2000 with chimneys, they assume 1.5 air changes an hour. If it's post-2000, it's 1. If it's latest building regs, it's 0.5. But in my experience, I've used 1 for this house, and I found that's too high when I've come back to actually look at the actual heat loss at the end of the day. But I think if you use 1 for a house that isn't too drafty, got modern windows, that would give you a reasonable estimate.
And using the wrong air change figure makes a big difference on your heat pump.
It does, as you can see. Even with 1, it's more heat loss through the ventilation losses than through the fabric of the building. It's relatively straightforward for people to create their own spreadsheet and to work out the heat loss that they're seeing. And so then what you do is just do that for every room and add them together, and you get a good feeling for the heat loss of your house. And you can also try different things, like if you were to insulate it, you can reduce the U value and see what the impact of that would be. The other thing I was going to look at was another tool which is called HeatPunk. So HeatPunk is a great little tool and it's free to use. Just look up heatpunk.co.uk. So if I look at a basic project, you can effectively create a floor plan very easily. Now, I won't go into a lot of detail here because they've got excellent videos on how to use it. You can size the room by just pulling a corner to whatever size you think whatever size the room is. But you can also do custom walls. So if you want to add a material, you can go in here and, well, they've got a lot of standard wall configurations. There's videos for all this, and it's really quite intuitive. From the tasks, you can do plans. I've done the plans, but if you then go to heat pump, it will then give you a breakdown for every room in terms of how much heat loss you're losing through the walls, floor, ventilation loss. And from that, you can get a good idea of room by room and for the whole house. It's a very good tool for looking at your room by room heat loss, and it's free. There are a couple of other tools. Tristan Lee's got a spreadsheet tool. Again, I won't go into detail. He's got full instructions, but it's a spreadsheet online where you can put in the details. He's got instructions how to use it. My intention is not to go into the detail, but to try and encourage you to do your own heat loss calculations, because they're critically important. There are some good tools around. You can then make sure that you're satisfied that the size of the heat pump you're getting put in your property is the correct one. The other thing I would recommend you do is look at how much energy you're using with your gas boiler, for example, if you move from gas. So you can download all your smart meter data, convert that into kilowatt hours, and allow for the efficiency of the heat pump.
So how easy is it to do that? So if I had a gas boiler, what would I need to do?
Well, you need a smart meter. So if so for example, with Octopus, you can go and download all your smart meter data
for the gas boiler.
For the gas boiler,
okay.
And it gives you in half-hour intervals the cubic meters of gas it uses.
Okay.
You can find online how much kilowatt hours in a cubic meter.
Yeah.
Then you assume gas boilers, say 80-85% efficient, depending on how old it is. And what I'd suggest you do is just pick a cold day, pick one of the coldest days, in last winter or whatever, work out the heat loss for that, and that'll tell you, you know, on a cold day how much heat you need to put into the house. You know, put together brick outer, you know, 300 mil, plus add a row. You can then put insulation in it, so you can say mineral wool back.